It's just another hectic weekday. The streets jammed, horns blaring, people rushing from one errand to the next. Close calls and near misses are simply part of the background noise of life in modern cities, something most of us have come to accept as normal risk. But on June 5, 2020, far above us and hidden behind the sun's glare, something no one on Earth could see was on its way. From behind that blinding light, an asteroid large enough to erase an entire city was streaking toward our planet, unseen, undetected, unstoppable. This was Asteroid 2020 LD, hurtling faster than a rifle bullet. It flew past Earth at a distance less than 4/5 of the way to the moon, and not a single telescope on the planet spotted it in time. Only 2 days after the close pass, when it emerged from the Earth's shadow and began moving away, did astronomers even notice it had been here. Our planet is already tens of millions of years overdue for an asteroid strike on the scale of the one that wiped out the dinosaurs. Counting on pure luck is a dangerous survival strategy. 2020 LD measured around 140 meters in diameter, well within the range to be classified as a near-Earth object, NEO. NEO are asteroids or comets that come within 45 million kilometers of Earth's orbit. This one passed only 307,000 kilometers away, racing at about 27 kilometers per second. A direct hit would have obliterated a city in seconds. For perspective, the famous meteor crater impact near Flagstaff, Arizona, 50,000 years ago came from an object only 46 meters across, traveling at 15 km/h, far smaller and slower than 2020 LD. Or take the Chelyabinsk meteor of February 15, 2013, which injured over 1,300 people in Russia. That rock was much less massive, yet still caused widespread damage. 2020 LD was the largest asteroid to fly so close since 2011. And the year before, in 2019, another 100-meter asteroid nicknamed the City Killer 2019 OK passed only 73,000 kilometers from us, also from the sun's direction, and was spotted at the last minute. Despite our ability to detect galaxies billions of light years away, spotting asteroids near Earth remains surprisingly difficult. As of now, only 5 have ever been discovered before actually impacting. The problem isn't just their smaller size compared to stars or planets, though that's part of it, but also their faint reflectivity. Most asteroids are dark, making them nearly invisible if they approach from the sun's direction. With ground-based telescopes, our primary detection tools are also limited by weather. A cloudy night could mean a dangerous rock slips past unnoticed. Why not use space telescopes? While they excel at imaging distant galaxies, they aren't designed for nearby, fast-moving objects. Even when we know where to look, asteroid orbits are tricky to predict. Their paths are influenced by gravity from the sun, planets, other asteroids, and even subtle forces like the pressure from sunlight. A tiny miscalculation can throw predictions off by millions of kilometers over time. Asteroid tracking as a science is relatively new. The first asteroid ever discovered was Ceres in 1801 by Giuseppe Paisi, a giant 1,000 km wide body between Mars and Jupiter, now reclassified as a dwarf planet. Since then, astronomers have cataloged tens of millions of asteroids, most in the asteroid belt. But some drift into unpredictable orbits that bring them dangerously close to Earth. Today, we've identified 27,440 near-Earth objects. 117 are comets, the rest, asteroids. Of these, 2,270 are labeled as potentially hazardous asteroids, large enough and close enough to cause serious regional damage if they struck. About 150 exceed 1 km in size, big enough to threaten global civilization. How often do such impacts happen? The moon's crater-covered surface gives us clues. Earth has been hit just as often, but erosion and geology hide most scars. Tiny space rocks constantly bombard us, adding roughly 15,000 tons of mass to Earth each year. But we worry about the large ones. Astronomers use the Torino scale to rate asteroid threats from 0, no danger, to 10, global catastrophe. The dinosaur-killing Chicxulub impact 66 million years ago was a 10. The largest known impact in recorded human history was the Tunguska event of June 1908 in Siberia. An asteroid about 90 meters wide exploded in the atmosphere. flattening 18 million trees across 2,000 square kilometers. Its blast energy was equal to several megatons of TNT. Events like this are thought to occur about once every 1,200 years. 1-kilometer asteroids strike on average every 444,000 years. 5 km rocks every 20 million years, and truly massive 10-plus km extinction level impacts about every 66 million years. In 1998, the U.S. Congress tasked NASA with finding 90% of large NEO that could cross Earth's orbit. Several candidates stand out. Bennu 270 meters wide, traveling at 28 kms. If it hit, it could wipe out a country. Probability of impact in the next 300 years, 1 in 1750, with the riskiest date being September 24, 2182. Apophis 350 meters wide, 20 million tons, will pass extremely close on April 13, 2029, a Friday the 13th. Early estimates gave it a 2.7% chance of impact, the highest ever on the Torino scale, before later being ruled out. It will pass closer than some satellites and be visible to the naked eye in parts of the southern hemisphere. Florence 5 km wide, with 2 small moons. Passed within 7 million kilometers in 2017 and will again in 2057. A collision would be globally devastating. As the late Stephen Hawking warned, asteroid strikes are among the greatest threats to life on Earth. What could we do if one were coming? Large-scale evacuation is unrealistic. There's nowhere safe to go, and resources would be limited to the ultra-rich. If detected years in advance, space agencies have some options. NASA DART mission in 2022 successfully altered the orbit of a small asteroid moonlet, proving that kinetic impactors could work. Other ideas include gravity tractors, focused solar beams to vaporize material for thrust, or even painting part of the asteroid to use sunlight for gradual deflection. But space is full of countless small bodies. Any system will always be a partial safety net. Now imagine a worst-case scenario. A 10-kilometer asteroid, Torino scale 8, heading for Earth. Every current deflection plan becomes useless. An impact in a major city could vaporize everything within 100 kilometers instantly, leaving a crater large enough to swallow Hawaii. Outside this zone, survivors would face tsunamis 300 meters high, wildfires consuming half the world's forests, and magnitude 9 earthquakes leveling whatever remained. Debris blasted into space would rain back down for half an hour, triggering a second wave of destruction. A blanket of dust and soot would encircle the globe, plunging Earth into years of impact winter, killing most plants, then herbivores, then predators. Predators. Only the toughest microorganisms, like tardigrades, might thrive. Human survival would depend on isolated underground communities with long-term supplies. Yet scientists remind us that asteroid extinction is far less likely in our lifetimes than slower-burning threats. Climate change, nuclear war, pandemics, or even uncontrolled AI. The UN reports that human activity has already raised global temperatures by 1 degree C, bringing more extreme weather, rising seas, and biodiversity loss. Still, space humbles us. We are small in the cosmic scale, but not powerless. No asteroid currently poses an imminent threat, but the vastness of space means the big one could be out there, unseen, right now. The question of when is unknowable, until perhaps a giant rock comes from behind the sun again. Only this time, it doesn't miss. It's just another restless day on Earth. The streets are choked with traffic. Engines growl, horns blare, people weave through chaos, dodging close calls they barely notice anymore. This is life, busy, messy, predictable. But on June 5th, 2020, far above us, beyond the reach of our gaze, something was coming. High over the horizon, hidden behind the blinding glare of the sun, a silent monster was racing toward our planet, an asteroid, large enough to erase a city from the map. And no one, not a single observatory, not a single telescope, saw it coming. This was Asteroid 2020 LD. It tore through space faster than a rifle bullet, slicing past Earth at less than 4/5 of the distance to the moon. We didn't even know it had been here until 2 days later. By then, it was already leaving, vanishing into the dark, like a predator that had circled us and slipped away. Earth is already overdue for a catastrophic asteroid strike, the kind that ended the reign of the dinosaurs 66 million years ago. And in that moment, Our survival came down to pure, blind luck. 2020 LD measured roughly 140 meters across. That puts it firmly in the category of a near-Earth object, an asteroid or comet that comes within 45 million kilometers of our orbit. This one came far closer, just 307,000 kilometers away, at a blistering 27 kilometers per second. If it had hit, an entire city gone. To put that into perspective, the asteroid that slammed into what is now Arizona 50,000 years ago was less than half its size, moving slower, and still carved a crater 1.2 kilometers wide. Or consider the Chelyabinsk meteor in Russia, 2013, a much smaller rock, which injured more than 1,300 people. 2020 LD was bigger, faster, and came closer than anything its size since 2011. And it wasn't alone. The year before, in 2019, a 100-meter asteroid nicknamed the City Killer also came from the sun's direction, spotted only when it was already passing us. Here's the truth. We can spot galaxies billions of light years away, but detecting a rock racing toward us in our own cosmic backyard? That's still painfully difficult. So far, only 5 asteroids have ever been spotted before they hit Earth. Why? Because asteroids are small compared to planets and stars, and most are dark, reflecting little sunlight, an object approaching from the sun's direction, nearly invisible until it's too late. Ground-based telescopes are our main defense, but clouds, weather, and daylight limit them. Space telescopes sound like a better idea, but they're built for deep space, not for tracking fast, nearby objects. Even when we can track them, asteroid orbits are chaotic. Tugged by the sun, the planets, other asteroids, and even the gentle push of sunlight itself. A fraction of a degree in trajectory today could mean a miss, or a direct hit, decades from now. Asteroid hunting, as a science, is still young. The first asteroid, Ceres, was discovered in 1801 by Giuseppe Piazzi. It's over 1,000 kilometers wide, and now classified as a dwarf planet. Since then, we've cataloged millions, most in the asteroid belt between Mars and Jupiter. But some escaped its stable orbit and wandered dangerously close to Earth. Today, we've found 27,440 near-Earth objects, 117 comets, and 27,323 asteroids. Of these, 2,270 are potentially hazardous asteroids, large enough and close enough to cause regional devastation. About 150 of those are over a kilometer wide, the size that could threaten civilization. Impacts happen more often than we think. The moon's craters are a diary of billions of years of collisions. Earth's history is similar, but weather, erosion, and tectonics have erased most of the scars. Small meteors hit us constantly, adding about 15,000 tons to Earth's mass every year. But the ones we fear are rated on the Torino scale. 0 means harmless, 10 means global catastrophe. The dinosaur-killing Chicxulub event was a solid 10. The largest recorded impact in human history? The Tunguska event, June 1908, Siberia. A 90-meter asteroid exploded in the atmosphere with the force of several hydrogen bombs, flattening 18 million trees over 2,000 square kilometers. Events like that, roughly once every 1,200 years. A 1-kilometer rock, once every 444,000 years. A 5-kilometer rock? 20 million years. And a true planet killer, over 10 kilometers wide? Once every 66 million years. NASA mandate is to find 90% of the big ones. And a few stand out. Bennu 270 meters wide, moving at 28 kms. 1 in 1750 chance of impact in the next 300 years. Riskiest date, September 24, 2182. Apophis 350 meters wide, will pass closer than some satellites on April 13, 2029, a Friday the 13th. Early odds of impact, 2.7%. Now ruled out, but still the closest pass of its size in recorded history. Florence 5 kilometers wide, with 2 moons. And passed within 7 million kilometers 17. Will again in 2057. Stephen Hawking warned, an asteroid strike is one of the greatest threats to life on Earth. So, what's the plan? If an asteroid's detected years in advance, we might have options. In 2022, NASA DART mission smashed a spacecraft into a small asteroid moonlet and changed its orbit. Other concepts, gravity tractors that pull an asteroid over time. Focused sunlight to vaporize material and push it. even painting one side to use solar heating for a slow course change. But in reality, there are millions of rocks out there. This is cosmic whack-a-mole. Now imagine the worst. A 10-kilometer wide asteroid, Torino scale. 8. Impact inevitable. Every defense becomes meaningless. If it hit a major city, the fireball would vaporize everything within 100 kilometers instantly. Tsunamis 300 meters high would scour the coasts. Earthquakes of magnitude 9 would level what remained. Debris blasted into space would rain back down for 30 minutes. A second wave of destruction. Then, the sky would go black. For months, maybe years, no sunlight. No photosynthesis. Plants die. Herbivores follow. Then the predators. Only the hardiest microorganisms, like tardigrades, would endure. For humans, survival would depend on underground bunkers with years of supplies. Civilization would shrink to scattered pockets of desperate survivors. And yet, scientists say an asteroid apocalypse is far less likely in our lifetimes than slower disasters. Climate change, nuclear war, pandemics, AI gone rogue. But space is vast. The big one could already be out there, unseen, racing toward us from the sun's blinding direction. When will it happen? No one knows. Maybe never. Or maybe sooner than we think. And when it comes, it won't miss.